Hello everyone, it's Grumpy Gamer. Welcome back to another tutorial. Today I'm going to be covering Industrial Craft 2 power. Explain to you things like packets, what all the voltages are, what determines what the voltage is, that kind of thing, how transformers work, all that. It's not meant for beginners. I'm going to be covering a lot of things, assuming that you know what certain machines do and things like that. And I'm also going to be using some terminology you may not be familiar with. So if you're a total noob to the game, I just bookmarked this video because after you've been playing for a couple weeks, this is going to start answering some questions you have. But if you just want to know how to hook a generator up to an electric furnace to cook a piece of iron that you just got, this video is not going to show you how to do that. This video is going to show you how to hook up nuclear reactors and explain to you power losses and things like that. But anyway, if you're still sticking around, let me go ahead and start off. First concept to understand about the power is it travels around in what's called packets. Now, the packets contain EU. EU is energy units. That's what Industrial Craft calls electricity or energy. They call it EU, energy units. But it travels in packets. So let me come over here and I have a little area where I can show you that. This is an HV. Let me knock these down kind of in a way. There we go. You can see I've been playing around. So anyway, here's an HV array. And this thing produces 512 EU per tick. Now, a tick in Minecraft is a 20th of a second. So there's 20 ticks in a second. And so every 20th of a second, or every tick, this thing produces a packet. The packet sizes are 512 EU. That's where they get the 512 EU per tick. They're telling you the packet size. Over here, these are just regular solar panels. These produce 1 EU per tick. The packet size is 1. It's important to note that this solar panel right here produces just as many packets as this. Every tick, everything produces 1 packet. The only thing that changes is the size of the packet. So it's like the high-end stuff, like the high voltage arrays and the solar panels, not solar panels, the reactors, they produce bigger packets. So let me come over here and explain to you more about packet sizes. Packet sizes determine the voltage. The bigger the packet, the higher the voltage. You've got 4 voltages. You've got low, medium, high, and extreme. And if the packet has 0 to 32 EU inside of it, it's called a low voltage packet, or just low voltage. If it's got 33 to 128, it's considered medium voltage. If it has 129 to 512, it's considered high voltage. Extreme is 513 and up to 2048, I believe. Most of the time, if you don't have any power losses, all your machines or all your generating stuff you're going to be worried more about the 32 and the 128 and the 512 and all that kind of stuff. In other words, the MFSU puts out energy packets of 512 EU per tick. The MFE puts out 128 and the battery box puts out 32. And so if you have no power loss, this is what you're going to be feeding into your machines for packet size. But if you see there is a range, that's to take into consideration power loss. So let's say, for example, you've got medium voltage, which is 128, and for some weird reason you're losing half your power and you're only getting packet size of 64. Well, that still falls in the medium voltage range, and so that medium voltage, it will still blow up a low voltage machine. As long as if it's above 32, it's going to blow up the machine. So next, let me explain to you about transformers. Now, you may be familiar with transformers some, but I'm going to explain to you more about how this works. Let's say, for example, this cobblestone right here represents a nuclear reactor, and let's say it's producing 1024 EU packets, or that's the size of the packet. So I actually call that PEU. So if they say 1024 PEU, what they're referring to is the size of the packet, but that's getting way too deep. But anyway, let's say this reactor is putting out 1024 EU per tick. First of all, the only cable in the whole game that can handle that is HV cable. Now, this is 4X HV cable. In other words, it's insulated 4 times. Once you get to the point where you build nuke reactors, you're only going to want to go to 4x cable. There's no reason to build uninsulated wire or 2x wire unless you're just a total freaking cheapskate. I don't know, but build this 4x HV wire. But this is the only wire that will handle extreme voltages. Now, first thing you want to do when you got an extreme voltage probably is you want to knock it down to its more manageable size. So you want to knock it down to a high voltage. That's this right here. So this transformer right here will knock the voltage down to 512 EU per tick. Now we're taking 1024 EU per tick packages and knocking them down to 512. You might be thinking, well, I'm losing half my power. No, you're not. What's going to happen is the transformer is going to output 2 packets. So you're going from one big packet of 1024 to 2 packets of 512. So you lost nothing. You're just creating smaller packets. More of them too. So the next step would be your medium voltage transformer. That's going to knock the power down to medium voltage. That's medium voltage right here. And low voltage transformer will knock it down to low voltage. So if you're just wondering what all the transformers do, that's it. Now over here, these let me fly up a little bit. You see these horizontal cables, the lines, they represent the different voltage states. So on this wire we have extreme, on this one we have high, on this one we have medium, and finally on this one we have low. And so I'm going to show you what you can hook up to these different voltages. Low voltage, you're going to use the bat box for energy storage. For medium voltage, you're going to use the MFE. For high voltage, you're going to use the MFSU. And for extreme, there's no energy storage. So if you want to store energy, you got to use an HV transformer to knock it down so that you can tie it into an MFSU. But the cool thing is the machines, they take overclockers, and you can run your machines at any voltage. So here we have low, medium, high, and extreme. So you might be wondering how we do that. Well, first of all, for the low voltage, you don't have to do anything. For medium, you need to put 1 transformer upgrade in there. For high, oops, didn't mean to do that, misclicked. For high, you want to put 2, and for extreme, you'll put 3. So you can actually run all your basic machines off straight off a nuclear reactor if you want to. You just got to make sure and put 3 of those in there. So once again, that machine can handle low voltage, medium, high, and extreme. And so next thing I want to show you is, I was going to mention this, I forgot to mention this. This is a very important concept. Cable has a limit on how much what packet sizes it can handle. Like for example, this is copper. It can only handle packet sizes of 32. In other words, it can only handle low voltage. But all these cables, they will handle an infinite number of packets theoretically. So I could have, let's say I have, I don't know, say for example over here we have high voltage arrays. You can see right there I've got 10 or 15 of them. I think there's like 10 of them here. That's 5,000 something, or 5,120 EU being generated every tick. This cable right here can only handle packet sizes of 512, but since it can theoretically handle an infinite number of packets, you're okay. The only thing you have to worry about is different from real world wire. Real world wire, this stuff would melt, but in industrial craft, you just have to worry about the packet size. As long as the packet size is okay, you're okay. So we have massive amounts of electricity traveling down this line. So, but they're all small. They're all 512 volt packets. So that's important to note. Like if you want to, like say, let's say for example, I don't know what I have in my inventory. Let's say we have an electric furnace here, and I want to run this sucker at like a super high voltage. I'm sorry, feed a massive amount of electricity into it. I just have to put enough overclockers or enough transformers up there There's low, medium, high. So there we go. This thing should be able to power that up. There we go. It's already charged up. Let's see if we got anything we can cook. We got a little bit of sand, but yeah, let's go put the sand in there. When you throw all the overclockers in there, it'll speed it up. But you could actually, with this setup, you could put 13 overclockers in there. This thing will run out at max power. But anyway, the whole concept was this. I was going to show you that since these things will handle infinite number of packets, this machine gets all the electricity at once. There's no need to do this number right here, like to get more power into it. Like, let's say you had another set of high voltage arrays right here. You're not going to get anything by doing that. This one wire can handle all the electricity if you want. So instead of running a second wire, all you have to do is put more of these arrays on this end. Same thing. So generally you never need more than one cable wire running to a machine. Let's see if there's anything else I was going to cover this episode. Let's go back to over here. I explained the overclockers. Let's see if I had anything else over here to show you. Oh, I was going to cover power loss a little bit. The way power loss works. Oh, there we go. Let's set that today. Let's say a wire has 8. It'll say something like you lose power after 8 blocks. Let's do that. I'm sorry, after every 4 blocks. So there's 4. And there's another set. So let's imagine this wire. This is glass fiber, so it has a very low power loss. But let's say this wire right here had a loss of every 4 blocks. The way this works is here's a generator. Or that might be an electric furnace. Okay. Let's say that's a generator, and it's producing 10 EU per tick packets. So after 4, they will drop down to 9. After another 4, it'll drop down to 8. After another 4, it'll drop down to 7. Well, that's an important concept. So in the real world, the way this would work, if you had a power loss of 0.25 per block, it would work like this. You'd have 10, 9.75, 9.5, 9.25, 9, 8.75, etc. With Tekkit, with industrial craft, you only get the loss after that 4th block. So let's say you have a higher loss line, like I have already built it over here. Let's say this cable over here has a loss of 1 every 10 every 10 blocks. What you can do to prevent that loss, like let's say you can put something in line right here. This is actually a bat box. Because this line is less than 10, you won't get any power loss. Because this line is less than 10, you won't get any power loss. So if you're worried about power loss, put stuff in line. It'll kill the power loss. So it could be some kind of storage unit or even a transformer. It'll reset the power loss. And so let's go over here. Let's cover power loss just a little bit more now. These right here, the solar panels, they only produce 1 EU per tick. Important thing to note here is that these things can have 0 power loss. The packets are only 1 EU. So if you have any power loss, bam, it's dead. So power loss, some people, there's times you want to worry about, times when you don't. Let's say, for example, over here, this wire right here has a loss. I'm just making this up. Let's say this wire here has a loss of 1 every 10 blocks. And let's say, for example, we put a generator right here. This produces 10 E per tick. That's the packet size. So you got 10 E. The packet right here is 10, 10, 10, 10. When you get all the way down to here, it drops down to 9. You've instantly lost 10% of your power. So you may not want to lose 10% of your power. But now here we have the HV wire. This actually has a much higher power loss. This right here has a power loss of 1 per block. Now that's not a made up number, that actually is the loss of this one. I'm just trying to use nice round numbers, that's why I came up with 10 for that. But anyway, let's say this right here is a nuclear reactor and it's putting out packet sizes of 1,000. So the packet's got 1,000 EU in them. This thing has a loss of 1 per block, so here's what it's going to do is 1,000, 999, 998, 997, 996. Now this is 10 blocks. By the very end, you're down to 990. So we've lost 10 energy here. Over here, we lost 1. So you're saying, wow, that's a much bigger power loss. Oh, well, yes, it is. But if you look at it as a percentage, over here you lost 10% of your power. Over here you lost 1% of your power. So what these are good for, this HV wire, it's good for transmission lines for like nuclear reactors. If you have a nuclear reactor and say you want to send the power to 50 blocks away, yeah, you lose quite a bit, but at the same time you have a lot to start with. So this HV wire, you only use it for extreme voltages like coming off a nuclear reactor or something like that, but this is what you would use. So anyway, I'm going to go ahead and kind of wrap it up here. My voice is getting a little coarse. I've actually recorded this a couple times because I left something out or forget something. But anyway, I hope you found something in here helpful. I know some of it might be over your head, some of it might be redundant where you already knew it, and hopefully I hit that a lot of sweet spot where you learned something. But anyway, if you have any questions about this, let me know. I might have just left something out, forgot to mention something. So if you have any questions, just ask me in the comments. A good chance I may know the answer because I'm pretty knowledgeable with this stuff. I don't consider myself an expert, but if you're fairly new and you're wanting to just take it to the next level, hopefully this video will help. But have any questions, let me know. If you enjoyed this video and you'd like to see more of them, just subscribe and you'll get informed whenever new videos come out. But as Grumpy Gamer, we'll see you next time.